Hi class, in this video we'll be working some sample size problems. A standardized test is designed so that the mean test score is 100 and the standard deviation is 22 for the population of students. We want to find the sample size necessary to estimate the mean test score of statistics students that took the exam such that it can be said with 95% confidence level that the sample mean is within 8 points of the true mean. And we want to assume that sigma is 22. All right, again, that's that standard deviation for the population. Okay, so we read the problem and we said we want to find the sample size necessary. So what the problem is asking me to do is find n. Okay, so let's look at first what information I'm given. So I know that my standard deviation is 22. All right. My mean is 100. So x bar is 100. Because I'm trying to estimate the population mean, I'm going to take that 100 to be the sample mean. And then we have a 95% confidence level. So we have our confidence level is 0.95. And then our sample mean needs to be within 8 points of the true mean. Now, anytime, again, you see that wording within a certain thing, a percentage or points or whatever, that indicates your margin of error. So E equals 8. Just a quick note, unlike with the proportion, where you're given a percentage as your E and you need to convert that to a decimal, we are going to leave our E just as it is, as 8. Okay? We're going to match the units. So here, the units are points for your test, so E is going to be those 8 points. So we're not going to change that to a decimal or anything. Okay? So now that I have all my information in order, I'm going to go to my formula chart to see if I can find a formula for n that uses some of this information. Okay? So I know that I'm estimating a mean, so I'm going to find mean under my parameter column here. I have 2 rows for mean. So then I'm going to look all the way to the rightmost column because that's where I see sample size. And I see I have one formula for my sample size n. And that is going to be n equals z alpha over 2 times sigma divided by e, all that quantity squared. All right, well, I know from the problem that I'm given sigma and I know E. Now, what about the z alpha over 2? So to look at that, I'm going to come over to the rightmost little column called critical value z-score. That's off by itself. It's not in the main table. And I notice right at the bottom, I see the 3 common z-scores for confidence levels of 90, 95, and 99. So I'm not even going to use the calculator. I'm just going to use what this gives me on the table because I have a 95% confidence level. I can just use the table and grab the z-score from there. And for a 95% confidence, I need z to be 1.96. All right, so let's record that. So I know that z alpha over 2 is 1.96. Okay? Otherwise, you would look at that table and use the calculator functions. Okay? And then n is z alpha over 2 times sigma divided by e, and that whole quantity is squared. All right, so let's fill in everything into that formula. So z alpha over 2 is 1.96. And then sigma is 22. And then E is 8. Right? And then I square it. Okay, now notice that in the calculator, I'm going to put 1.96 times 22 divided by 8. I'm going to put the whole thing in parentheses, and then I'm going to square it. Okay? Because I want to make sure the calculator squares everything. Otherwise, it's just going to square the number that's closest to the exponent. Okay? and I get 29.0521. Now remember, anytime we are finding a sample size, we are going to round up to the nearest integer. We're not just going to round to the nearest integer, but round up. All right, so where normally you would maybe round this to 29 and just chop off the decimals, we are going to round up to 30 because we want to make sure that we hit our target and be over our target for our sample size. It's always better to be over than under. So I need at least 30 people in order to estimate within 8 points my true mean. All right, you should be good to go for that example. All right, this next example is going to be over student earnings. So how many students must be randomly selected to estimate the mean weekly earnings of students at one college? We want 95% confidence that the sample mean is within $5 of the population mean, and the population standard deviation is known to be $63. All right, so a few things I note. The first thing that this problem says is how many students must be randomly selected. So that tells me that we are going to find n. Okay? So remember from our last slide that n equals z alpha over 2 times sigma divided by e all squared. Okay? So I want a 95% confidence level, so my CL is 0.95. Well, we saw just a half second ago, that means that my Z alpha over 2 is going to be 1.96. All right, again, you would just look at your formula chart because it has that 95% confidence level Z-score already written for you. Okay, so after we have that, we need our sigma. And my problem says that the population standard deviation is known to be $63. And then we need E. And the problem states that we want the sample mean to be within $5 of the population mean. So E is going to be $5. Again, I'm going to stress that unlike with the proportion where we converted our percentages for our margin of error into a decimal, you're going to leave this alone. Okay? So then N is going to be 1.96 times 63 divided by 5, and all of that squared. All right, and then once again, I'm going to put that in my calculator. And I get 609.892. But again, I need to make sure that since I'm working with sample sizes, even though the problem doesn't tell me this, I'm going to round to the nearest up to the nearest integer. So always round up. And so I'm going to have 610 people, or college students specifically in this case, that I need in my sample. All right, and you're good to go.